Greetings, geometers. We are here to do a review for the first half of our circles unit. Really, we're doing it as sort of 2 units. And this is the first half of it, basically. Mainly about tangents and angles in and around circles. So let's start out here. The circumference, remember the formula is 2 pi r. So if we know that the radius is 5 inches here, and I'm sorry this is very shadowy. I don't know that I can do much about that. But if we know the radius is 5 inches, then 2 times pi times 5 is 10 pi. Next, this is one of those where I think I'm going to go ahead and find everything I can here and then look at what's being asked for. This is 90. This is 60. Remember that anytime you have a diameter, which RT is a diameter, everything on one side of RT has to add to 180. So 90 plus 60 is 150. Subtract that from 180 and you get 30 here. This is a vertical angle with that angle, so that's also 30. And remember, everything on one side of RT adds up to 180, so this would be 150, so that 150 plus 30 can be 180. Okay, so these are all central angles because they have their vertex at the center of the circle. So SOT is a central angle, 30 degrees. ROS, 150. Measure of arc QR. Remember, the arc is the same as the angle on central angles. QSP. That's Q passing S and going to P. So again, watch how I did that. We go from Q, we have to pass S before we get to P. So all the way around there. So it's basically everything except this 60 degrees. So 360 minus 60 is 300 degrees. RQT. R passing Q and going to T. RT is a diameter, so that has to be half of a circle. The arc length of PQ and the arc length of RPS, we actually haven't talked about that yet. That's coming later. So that is not in our first half of the unit, so we're not going to do those. Next, we have circle L with diameter 10 centimeters, and I'm supposed to find the missing values. HLG is congruent to GLF. HLG, GLF, those are congruent. JLK is 5x plus 3, and that's degrees. JLH is 3x plus 9 degrees. Okay, we know that these two, from H to K, since HK is a diameter, everything over here has to add up to 180. So I can say, let me grab some scratch paper here. I could say 5x plus 3 plus 3x plus 9 equals 180. That's 8x plus 12 equals 180. Subtract 12 from both sides, and I get 8x equals 168. And I'm going to divide 168 divided by 8, and that gives me 21. So x is 21. Well, if x is 21, I can go back and plug in, let's say it right here, x is 21. 5 times 21 plus 3 for this angle. So 5 times 21 is 105 plus 3. So this angle KLJ or JLK is 108, which makes this one right here 180 minus 108, which is 72. And we can double check it by plugging in 21. 3 times 21 is 63 plus 9 is 72. If this angle is 72, HLJ, this is 72. And I can add all of these, and I say, well, I've got 72 plus 108, that's 180, plus 72. 180 plus 72 is 252. That's all the way around except for these two sections. So if I subtract 360 minus 252 and divide that into 2 pieces, each one of these has got to be 54. Circumference, if the diameter is 10, circumference is 10 pi. GLF, that's 54. FLK, 72. Arc FG, also 54, these are all central angles. Arc HJF, that's from here going around through J all the way to F. So that's everything except for the 54 and 54. So I'm going to do 360 minus 54 minus 54 minus 108 and get 252. Okay, arc length again is something we're going to cover later in our second part of the unit. Okay, down here we have CD is 16. All right, and BF is 12. CD is 16, BF is 12, BF, or that means FD is 12. Okay, I'm supposed to find AC. Well, let's see how we can do this. If I draw CF, which pretend that meets up, sorry. This is a right triangle over here. One leg is 12, one leg is 16. So 12 squared plus 16 squared gives me 400, which is 20 squared. So this is 20. The hypotenuse is going to be 20. Well, that's a radius of this circle. So FA would also be 20. And then let's see. DF, we already know that. So the radius is 20. AC, where's that? That's right here. Let's see. Do we know? Trying to see if we know this is a right triangle right here. Can I prove that that's a right triangle? I don't know that I can. So don't worry about that one. I'm trying to figure out if I can. Let's just say no for now. All right, next page. Number 20. Assume that segments that appear tangent are tangent. That's just a way of saying, yes, this doesn't just look tangent, it is tangent. So we know this is a right triangle. Okay? So if this is x, then this is x. This is a lot like the one you did on your quiz where it was r and 11 and 8. Okay, so I'm going to say leg squared plus leg squared is 8 squared equals, this whole hypotenuse is not 4x, it is x plus 4. And we have to square it as one whole thing. So in other words, I'm going to multiply out x plus 4 times x plus 4. When I do that, using either distributive property or FOIL, I'll get x squared plus 8x plus 16. On this side, I get x squared plus 64. Now the nice thing is, because I have two x squares, if I subtract one from either side, the other one's gone on the other side as well. So now I've just got 64 equals 8x plus 16. Let me subtract 16 from both sides. And that's going to give me 48 equals 8x. Divide both sides by 8, and I get x is 6. So 20's x is 6. Angle ACB, we already said that was 90 degrees. Angle BAC. Well, let's see. How can we find angle BAC? If we know that x is 6, this is 6, then this whole side is 10. This is 6. This is a right triangle. I can use right triangle trig. I can say, well, that basically is me saying I want to find angle BAC is this angle of a right triangle. So I could really use anything I wanted, tan, sine, cosine. I'm going to use sine. Sine, it would be opposite over hypotenuse. So sine of theta equals 8 over 10. That means that theta will come from doing the inverse sine of 8 over 10. And when I do that in my calculator, and you could reduce that if you wanted to, it wouldn't hurt anything, I get 53.13 degrees. So let's call it 53.1 degrees. All right, next. For 23 to 30, use circle D, where the measure of angle 1 is 3x minus 5. 3x minus 5. Measure of angle 2 is 6x minus 4. Right away, what occurs to me about those two is they're going to have to add up to 90, because anytime you have a triangle inscribed in a circle where one side of the triangle is a diameter of your circle, it has to be, a right triangle. Every right triangle has two angles that aren't right, and they always add up to 90. So I can say right away now, 3x minus 5 plus 6x minus 4 equals 90. And then solve. This is 9x minus 9 equals 90. 9x equals 99. X equals 11. So this angle is 3 times 11, that's 33, minus 5, that's 28 degrees. 28 degrees here. 6 times 11 is 66, minus 4 is 62 degrees. I can kind of check myself. Do 62 degrees and 28 degrees add up to 90? They do. So we have x is 11. Circumference. Let's see. What do we know about this one? We know that AC is 8. Okay, so that would mean 2 pi r or pi d. There's two different ways to do circumference. 2 pi r, if this whole thing is 8, then r is 4. So 2 times 4 times pi is still 8 pi, or pi d. Okay, angle 1, 28 degrees. Angle 2, 62 degrees. Measure of arc BC. Arc BC is intercepted by angle 1. So whatever angle 1 is, 28, is half of the measure of this arc. So 28 times 2 gives me 56. Arc CAB, that's starting here, going around, passing A before getting to B. Well, that's everything except the arc I just found. So 360 minus 56, which is going to be 304. Again, we have not gotten to arc length, so skip those. All right, this is the one that I really think I chose this review for, because we haven't done one of these in a while. And I wanted to remind you that when you have a circle inscribed inside a polygon of any sort, basically it's ice cream cone theorem. In other words, we have an ice cream cone here, where these two sides are the same. We have an ice cream cone here, excuse me, where these two sides are the same. Because remember, the rule is if you have two tangents from the same point to the same circle, so here's one, HJ is one, and HN is the other, then they have to be congruent. So if HJ is 9, HN is 9, NM then is 16 minus 9, so that's 7, which means this is 7, which means KL is 11 minus 7, so it's 4. It's okay if it doesn't look bigger. We go with what measures were given, not what it looks like. And X is 4, and the perimeter of the whole thing is 16 plus 11, so that's 27, plus this side is 9 and 4. Plus 9 plus 4 is 40. All right, we're closing in on the end here. Last few problems. For 33 and 34, find the missing values. Okay, one thing we know is that all of those arcs, sorry, I need to move it down a little bit. All of those arcs cover the whole circle. We've got 5x here, 8x, 3x, 2x, that's the whole circle. So I can say that they all add up to 360. Which, let's see, that's 2 plus 5 is 7, plus 8 is 15. 18x's adds up to 360. So I can divide both sides by 18 and get 20. So x is 20. So the measure of angle 1, now I need to figure out the actual arc measures. If x is 20, this angle is 3 times 20, which is 60. And this is 5 times 20, which is 100. Now I chose to find those two arcs because here is angle 1, The intercepted arcs for angle 1 are the one in front of it and the one behind it. So 160 are the two arcs that go with angle 1. The 2x and the 8x go with angle 2. This is an angle that has its vertex inside the circle, so I'm going to say angle 1 is 1/2 of 100 plus 60. 100 plus 60, so measure angle 1, I can write this. 1/2 of 100 plus 60. 160, half of that is 80. Next, assume that segments that appear tangent are tangent. So they're telling me, boom, that's a right angle. Same thing here. Boom, right angle. Okay. And let's see. 150 is over here. X is the whole rest of the circle. So just subtract 150 from 360 and we get 210. Last but not least, X is an angle that has its vertex outside the circle. Outside, the rule is 1/2 the difference between the two inscribed arcs. So X is going to be 1/2 the difference between 95 and 25. 95 minus 25 is 70. Half of 70 is 35. Y is an arc, and we have an inscribed angle that intercepts that arc. That's the one that's marked 40. So an inscribed angle is half the arc it intercepts. So 40 is half of y, so y is 80 degrees. And Z. Well, now that we have y, we know 95 and 100 and 25 and 80. We know everything else around the circle. We know arcs all the way around the circle except for Z. So I'm going to add up all those other arcs. 95 plus 100 plus 25, don't forget that little guy right in there, plus 80 is 300. Subtract that from 360 and you get 60. And number 40 is the last one you're doing on this. So you are done.